Hi, I'm Cameron, and welcome to Home Alliance Academy. Multimeters are an essential tool for checking electrical circuits and components.
Whether it's checking a battery, extension cord, or troubleshooting an appliance, multimeters can help determine exactly what has failed. If you've never used a digital multimeter, or if you're looking to refresh your knowledge, then this episode will get you started. First, we'll review how electricity works. Then we'll learn how to test for continuity. Finally, we'll do some safe voltage tests and talk about the limits of testing current. Let's begin. To understand what a multimeter can measure, let's quickly review some fundamentals. Electricity is the movement of electrons from one atom to another. The flow of electrons through a wire is somewhat similar to the flow of water inside of a pipe. Voltage, or potential difference, is the pressure from the power source that pushes the electrons through the wires. Current, or amperage, is the flow of electrons within a circuit. Resistance measured in ohms is the amount that a material will resist the flow of electrons. Conductors have low resistance, allowing electrons to move easily through them. Insulators have an extremely high resistance to the flow of electrons. For example, copper wire is insulated by a plastic sheath. If we connect these wires together to a power source, we get a complete electrical circuit. Batteries provide direct current or DC power as the current always flows in a single direction. This is represented by a dashed line on the multimeter. Your home runs off 120 volts alternating current or AC power. The direction that the current flows is changing 60 times a second or at 60 Hertz. This is represented by the sine wave. In either case, the electrons always need a continuous path to return to the source. This is continuity, or a closed circuit. If we disrupt this path with rubber, plastic, or by air in the case of a broken wire, the electrons will not flow as there is no continuity. This is an open circuit. In many cases, the lack of continuity in a single component will prevent an appliance from working properly. To set up the multimeter, plug the meter leads into the terminals. Usually, they are color-coded red for positive and black for neutral or common. Some meters will have two positive terminals. One terminal is for voltage and resistance, and the other is for measuring amperage. Always inspect the multimeter before use. Never use a multimeter that has a damaged case or that tests with nicked or damaged insulation. To be safe, always hold the multimeter from the insulated handles. Even 120 volts in your home can be deadly, so use caution before testing any live voltage. If you're unsure at any point, then it's best to contact a professional. Your model might look a little different, but all multimeters have the same common controls. Volts AC, volts DC, resistance in ohms, and resistance with tone, which will beep when there's continuity. As well, you can test for capacitance, amps AC, and amps DC. Some multimeters are auto-ranging and will automatically adjust the units displayed. In other models, you'll have to set the multimeter for the most accurate range. For example, if we test continuity at the 20K setting and we get a reading of 2.6, then the resistance is 2600 ohms. To test a component for continuity, first set the multimeter to the ohms or resistance with tone setting. Safely disconnect the power and remove the wires or connectors. Now, remove the component or isolate it. Next, touch each probe to each component terminal. If there is no continuity, then the multimeter will display OL or open loop. This means the component will need to be replaced. If there is continuity, you'll get a reading above 0 ohms, but the resistance will vary between load or non-load components.
Thank you guys so much for taking the time to watch, and we'll see you on the next one.